Alright, today I'll be going over OSPF. OSPF is a dynamic routing protocol, and it replaces static routing protocols, of course, and it's much more efficient and widely used today. So I'm going to just be going over some basic configuration of OSPF, and as you can see here, I've got my router topology. I've got 4 routers, and right now they have not been configured other than IP addresses on the interfaces. And so I've got these here, and they may look confusing at first, but I'll go over everything. So I've got them connected, but they cannot reach the next hop router. Basically, they can only reach their neighbor router. So R3 can reach R4 and R1. R1 can reach R2 and R3, but R1 cannot reach R4, and R3 cannot reach R2. So we're going to configure this where they have, they can ping all over the network with no problems. So I'm going to show y'all how to configure router OSPF here. Alright, so I've just gone into configuration mode, but I'll start over here. Alright, so we're going to exit. We're going to press return to get started. We're going to enable configure terminal. Alright, so from here, you're going to type router OSPF, and then it's going to ask for a process ID, as you can see here. So we can use anywhere from 1 to 65,535, but I'm just going to use process ID 1. This does not have to match between routers. It can be any number. Alright, so within this, I'm going to press the question mark, and we have a lot of commands. A lot of these are past the CCNA pay grade, but we'll be using a couple of these. The area command, we'll be using the area command today. The auto cost I will not be using, but this just calculates the cost of the bandwidth because OSPF uses cost to determine the best route to the source or destination. So it will be using the auto cost bandwidth feature, and you want to make sure that all your links are consistent. That way you don't take a slower path than a faster path. Alright, then we'll have the log adjacency changes. I won't be going over that, but that's pretty simple. That just shows, that just filters what you want to see. And then we'll have neighbors. Now I'll show the neighbors, but we won't specify any neighbors today. Then the network command's the main one we're going to be using. This on a router tells what networks it needs to be routing over. And then the router ID, I'll go over the router ID as well. So first we're going to use the network command. Network. Alright, so it's going to be asking for the network. Alright, so here I have router 1. Right here, sorry about that. I have router 1, and it is connected to the 203.1.1.12/30 network and the 203.1.1.0/30 network, okay? So I'm going to advertise these networks to this router. So I'm going to type in 203.1.1.0, and then usually you would put a subnet mask here, you would think, but it's asking for a wildcard here. So what we're going to do is we are going to invert this. So if I put a subnet mask for /30, that would be 255.255.252. However, for a wildcard, that's inverted. So this would be everywhere a 255 would be a 0, and then the 252 would be a 3. So 0, 0, 0, and 252 taken away from 255 is 3. But that's a tight window. This allows for just this network, if that makes sense. If I opened it up, notice how we have 203.1.14.1.18.1.112. It goes all the way up. This whole addressing scheme goes all the way up to 255. So the network, if this was a /24, the network would be 203.1.1.0, and the broadcast would be 203.1.1.255. So instead of doing that, I'm going to do a /24, which is going to be 0.0.0.255. That's how I'm going to advertise the network, just in case we want to introduce some routes later. So I'm going to press enter, and it's going to say incomplete command. Now, why does it say that? Because in OSPF you have areas, as I mentioned up here. So we're going to go back into that, and we're going to press question mark. It's going to say it wants the area, so it's going to ask for the area and then an ID after that. So we're going to set it, and you can see how many area IDs you can set. It's a lot. But we're going to just do area 0 because 0 is for single area OSPF, and it's always the backbone. Alright, so we set it to 0. Now, we're going to go back and do the exact same thing, but instead of retyping the command, I'm going to press up on my keypad, and I'm going to enter in 12. 203.1.112, and then a /24 wildcard mask. Okay, and then area 0. Now these networks are advertised. Alright. Now, I am going to go to router 2 and configure router 2 as well. Enable, configure terminal. Router OSPF and process ID, I could use 2, I could use 3, I could use 4, but just to keep it simple, I'm going to use 1 again. It doesn't matter, it doesn't conflict with the one on router 1. So now we're going to do network. Now, what 2 networks are connected to router 2 here? I know it's hard to see that. This is router 2. It's the 203.1.1.8 and the 203.1.1.12. Okay, so we are going to do that. 203.1.1.12 first, 0.0.0.255, and then area 0. Now that is advertised. Now instead of typing that, I'll just change this 12 to an 8 to cover the other network. Now watch this. Within this, if we wait a couple seconds, we're going to get this notification. This is a level 5 syslog, system logging, I guess, and that means it's a notification, so it's just notifying us, nothing wrong. And it's just showing us that neighbor 203.1.1.14 right here. This is the .14. You can see 13's here, 14. Went from loading to full. Loading done. So that means basically that we now have an OSPF neighbors. These guys are neighbors. They're sharing information. They're like, hey, you know, you have the same area as me, you know, and here's my addresses. Here's, you know, I'll give you mine, you give me yours, and that way we can route to each other. So now I'm going to go to router 4 and configure OSPF as well. Enable, configure terminal. Router OSPF 1. I could use 4, 5, 6, it doesn't matter. Network. What 2 networks do I need to advertise here? 203.1.1.8, 0.0.0.255, area 0. Alright, network 203.1.1.4, 0.0.0.255, and we're going to get some messages here. Notice how we just got the message from 203.1.1.13. Okay, so we got an adjacency here. Alright, so I'm going to complete this command here. Area 0. Alright, so now R4 recognizes R2, and it's like, hey, we're neighbors, buddy. R3 still doesn't have anything, so R1's looking. It's sending out LSAs, trying to figure out if it has a neighbor on this link, and it's about to. Configure terminal. Router OSPF 1. Network 203.1.1.4, 0.0.0.255. Remember, this is just the wildcard mask for /24. If this was reverse, this would be 255.255.255.0. This is just reverse. You just subtract. Alright, and then area 0. Alright, instead of typing that out again, I'm just going to do .o. Well, sorry, there we go, there's another one. Those syslog messages mess me up, and there's a way to fix that, and I'll show that in my syslog video. But now we're going to exit. But these right here, these 2 messages are our neighbor adjacency. So now it's telling us right here, if we look at this, did I set that? Here we go. Yeah, OSPF 5 adjacency process 1 neighbor 203.1.1.14, which is right here on gigabit 0/0, is up. Now, why is it saying neighbor 203.1.1.14 and not .1.1.1? So, if I exit, and I do, I show IP, OSPF, press the question mark, I have a lot of stuff. So border routers is going to be used for multi-area. We don't have any border routers because they're all in the same area here, so none of them are bordering. Database shows the database, of course. We can go into that. This is going to give you all your information that you need for it. Okay, so you're going to have your different routers, your link counts and stuff. But we don't have to worry about that yet. We can go in and we can look at neighbors. So I'm going to type neighbor. All right. And R3 right here has a neighbor R4 and has a neighbor R1. Okay. This is not a neighbor because it's not the next hop over. So right here we have full DR and full DR. So we know that they're communicating based off the full, but what does DR stand for? It stands for designated router, okay? Within OSPF, there's an election. So if you have a bunch of routers, you have what's called a designated router and a BDR, which is a backup designated router. And what these routers do is they receive what's called LSAs, link state advertisements from the other routers. And so if you have, I don't know, 30 routers sending link state advertisements to everybody, it congests your network and it's awful. But if you have a BDR and a DR, and they're the only ones receiving link state advertisements from all the routers, it doesn't congest your network as much. So right here we have 2 DRs, and that's just because I haven't set an election process yet. So what we're going to do is we're going to go back into configure terminal, and we're going to set some router IDs. So what we're going to do is router OSPF 1, go back into our protocol, and we're going to go router ID. Since this is router 3, we're going to go 3.3.3.3. It can be an IP address or whatever. So now I'm going to type do write to write the memory and save the configuration. And then I'm going to do reload. And I'm going to confirm. It's going to take these links down, of course, because this router is now off. And it's going to set the router ID for R3 as 3.3.3.3. Okay? So by default, the router will pick the IP address on the interface. So I'll show you here. Do show IP interface brief. All right, we have gigabit 00, which is right here, this link. And it has 203.1.1.1 configured on it. But the router ID of R1 is 203.1.1.14. Okay? It picks the highest IP address on the interface. So the router ID for R2 is 203.1.1.13. It's .9 for R4, and it was .5 for R3, but now it's 3.3.3.3, okay? So now, if and there it is, see, it's going to show us here. Here's our notification, adjacency change. Process 1, neighbor 3.3.3.3, okay? Before, as you can see up here, before I took it down, or when I took it down, it shows neighbor down, it shows .5 because that's the highest IP address. So that's your router ID, and router IDs, and I'll go into this more in depth in another video, but router IDs determine who becomes the BR and BDR, because that's important in a network. And the backup designated router, the BDR, becomes the designated router if the DR goes down. So it's kind of like president and vice president. If the president's killed, the vice president fills his position. This is just to avoid any network downtime, which is very bad if it occurs. So the process happens almost instantaneously. So now I'm going to do show IP neighbors. IP OSPF neighbors. Alright. So now we have BDRs here. Now this is still messed up, but because we have this, R1 is now the DR because it has the highest IP address configured on an interface. Okay, these are BDRs now, backup designated routers. And then this should take a little while to update, but once it updates, this one of these BDRs will go away, and I believe it should be this one. R3 will become just a OSPF router, and R2 should become the BDR officially. So that is it. We are going to ping to make sure we have connectivity here. I'm going to do ping. Now from R2, I could always ping R1 and R4. I should have demonstrated that, but I didn't in the beginning of this video. But now I'm going to try to ping 203. I'm going to ping R3's G00 interface. So 203.1.1.2. And there we go. So it's going to go. And I will show you in simulation mode. So I have the ping here. When I press it, here is our ICMP packet. Okay. I'm going to go forward. It is going to take the best path. Now all of these are gigabit links, so they all have the same cost. So it is going to choose the path from R2 to R1, R1 to R3. So it's skipping R4, and then it will take that path back. Now they can ping. Alright, it's going to continue sending them messages. R4, same thing. Do ping. And that do just elevates the privilege of the show commands. So do ping 203.1.1.14. Alright, and we have a 100% success rate. And let's see which path this takes. So it can, right now, it could take R2 or R3. We're going to see. It's going to take R2 path. Okay. There we go. Now just to show you how OSPF adjusts, I'm going to go, let's say, right here, I'm going to go into R2 since we know it took this path. And in the physical tab, I'm going to power it off right here. And you see these links go down, right? Oh no, that's not good, is it? If we had a static route, R4 would still be trying to send packets to R2, and we'd be losing network traffic. So right here, alright, so a bit of a dumb mistake, and I'll make mistakes, but the reason it wasn't pinging is because I was pinging 203.1.1.14. 14's down. This link's down. What I was trying to do is ping from R4 to R3 to R1 to this interface, which is obviously down. Not the actual interface on R1, but this link between the OSPF links is down. So if I change this to ping 203.1.1.1, it should go through. So now it's going to take that path. And I can show that by doing this. Enable, configure terminal. If I set a loopback interface, which is just a interface to ping a device, so we can do 1.1.1, 255, 255, 255, 255, directly connected. All right, exit. Show IP interface brief to make sure it's there. There it is, loopback. If I do this, cut back on router 2. Alright, it's booting up. Actually, we don't even need router 2, and I don't think I saved that configuration, so it's going to erase the configuration there. But if I ping 1.1.1.1, ping the actual device, it shouldn't go through because I haven't advertised it. So if I go in here, you know what, that's it. Bye. Alright, so yes, it goes through here. And I was just messing around with the loopback. but the ping goes through, so it took a different route since this is down. That's how OSPF works. It chooses the best path, and if a link goes down, it updates, goes around. Packet tracer's a little buggy with it sometimes, but that's how it works. So thank you for watching. I hope you enjoyed, and leave a comment, like, and subscribe.